Hello, everybody, and welcome to another JS Drop sponsored and presented by This Labs. My name is Rob Osell. I'm a VP of Innovation. Today, we're super excited to be talking about the React compiler and answer every single question you've ever had about the latest version of React. Presenting today is going to be Jesse. Jesse, do you want to introduce yourself?
Huzzah! Hello, everybody. Share screen. I would love to introduce myself, uh, but that's on the second slide, I think. We'll start with the second slide. Who am I? I'm Jesse Tomchak. I like to call myself a super senior developer at this point. You may have gone to school with these people who are super seniors who are like repeating their senior year. And it's not really for lack of effort. It's really that this is the spot in the sort of career pipeline where I enjoy being, sort of working on advanced stuff, not in charge of people, as little meetings as humanly possible, right? And working in back and forth in startups and enterprise, mostly in JavaScript, but I'm happy to work in Ruby, Rust, and I think the Node ecosystem is a hot mess. So we're just going to start right out of the gate with a hot take. You can see me in some of my famous films. There's me as Zeus. I've been in a bunch of other films. I'll let you look up my discography. Movieography? Discography. So we're not actually going to talk. So this is Rob said that everything about the latest version of React, but that's not entirely true. We're going to talk about the React compiler, which is not React 19. So let's start that right out of the gate. The compiler and 19 are separate. The compiler is a library that you should only use with 19. But guess what? Today we're going to use it with 18 just to see what it's like. So today we're going to work on the compiler. What is it? How in the world does it work? And then we're going to sort of learn by building our own version of compiler runtime. And if you're thinking, that's really ambitious that he's going to build a compiler in a JS drop, but we're not actually going to build a compiler. We're just going to build a runtime implementation function so that we know what it's doing. So, I mean, hey, you can say it's super ambitious, and it is. So we're going to hit a couple slides, and then we're just going to dive right into the code. I've got the chat open. Senioritis, yeah. Filmography, that's what you're looking for. My filmography. So, like I said, the compiler is a optimizing library for React components, independent of React 19. Now, it works in conjunction and isn't great with 18 and actually doesn't technically work at all, but we're going to patch it up a little bit. But it's just a library. And what does the compiler do? So you might know like Svelte and Solid and probably even Vue at this point. Most of our front-end frameworks have a compiler already. And we're not going to play pedantic Jeopardy where we're like, is this technically a compiler? Basically, we're going to take our React code, we're going to, as an input, we're going to modify it, we're going to follow some React rules, and then we're going to spit out a sort of transpiled version of our code into the sort of Babel pipeline. So we're not going to bytecode. We're not going to WebAssembly. We're not going to assembly language, right? It's React and components in JavaScript and JavaScript out. So the compiler itself is going to automatically optimize your React app components. And it does this, it knows, it's got a couple things. It knows all the rules of React, which is more than I can say for me. I know some of the rules, and then the rest of the rules I sort of just fudge when the ledger gets really mad at me, because they're pretty much like obtuse enough that I'm like, I don't really like, I'm not interested in the rules of React when I'm building a component. I'm interested in finishing my work for the sprint and production and getting it out to users. So like the rules of React are sort of like pretty low on my list. Like I can't rattle them off for you. Um, the reason I'm interested in the compiler, and I was like, oh yeah, let's talk about the compiler, is no more use memo or use callback everywhere. Asterisk asterisk. So I put this in here, and the idea of the compiler is to intelligently memoize and call back your React components for you so that you don't have to really do it yourself. Because if you've ever, like, we've all looked at the rules and we've used memo and we've used callback, and I would probably say 10% of us use them correctly all the time. And of that 10%, I'm not in that group. Like, there's this constant fight with use memo where I will just put like, what's it dependent on? Everything, because I don't have time to go through them one by one and be like, are you a primitive? Are you an object by reference? Are you like, I don't care enough. I just need you to stop rendering over and over and over. Like, so I will just add to the, like, my React rule is add to the list until it stops rendering. Right? I think we've all done this where you're like, add it, add it, add it, add it, add it, add it. Oh, good, it's done. It's finally stopped. Great. I think my favorite is when I saw someone, and I didn't actually know you could do this, as a memo dependency. If you JSON stringify a object, it becomes just a string, which is a primitive. So every time it comes through, it's a new string. And I was like, what? How is that even possible? Don't do that. Don't ever do that. But I was amazed. So when we talk about memoization and we talk about use callback, and you thought, oh, cool, I'm gonna be learning about the compiler. And then you show up and it's like, oh, use memoization and use callback are like the dirty housekeeping of React. It's like, why do I have to manually do this? And the good news is the compiler is going to do this for us, and we're going to go through an example ourselves. But when React under the covers is doing this comparison, if the dependencies have changed, I didn't know this until recently. It's not using triple equals. It's using object is. And there's some subtle differences that we don't have to get into because it's not relevant to shipping products. But it's good to at least know this in the back of your head that, like, if you get into a corner and you're like, why does this keep rendering? It's because the value is changing. That dependency is a different either primitive or the reference isn't the same. So like +0 and -0 is a triple equals, like that's true, but object is false. And there's a few other ones in here in our list that come up. So it's worth knowing that, like, when it's doing this dependency comparison, it is object is not just sort of triple equals. So we're going to make a little project, and we're going to, oh, good. Here's our little project right here. So here's our little project. It is the same old React counter. And you're thinking, oh my gosh, it's so amazing. I know. You're like, wow, I came all this way for React counter. So I've got a little project running. Let me bump this up and get some font size that is respectable so that everybody can see this.
Oh yeah, more than good. Yeah.
Is that good?
Yeah.
All right. So this project, React V18 with compiler, we're running React 18, and we're going to write it in with a compiler. So this is literally just npm create project -- template React, right? So it's nothing special. We've got our we'll bump this up a little bit. We've got our app, which has some sorted fruits, which I have listed some of my favorite fruits. If anyone knows what these other ones are, there are bonus points for knowing what a rambutan's is, or a horned melon, a quinoa. I can't even say some of these names. But if you go to your local Trader Joe's or your Whole Foods, you'll find some of these ridiculously like pokey fruits that are really good. Um, but this is the app that we're going to sort of work with, and it does a couple things. It's got two counters in it, and a random list of fruits that is hard coded in here. And what you can see over here in our console log is the header function is a separate, and the ordered fruits expensive compilation, right? Because there's always going to be one of these in your app where product has said, I want this ordered most recent to furthest away by time zone from west to east. And you think, that's really dumb, but okay. So you make this like expensive computation that takes like a while. So what we can see is that right now we just have our vanilla, right? The header's a function, the sorted fruits list is a function. Our counters are, this is our expensive fruit ordering. And you may be wondering why I have random UUIDs in here for the console logs. Thank you for asking. If you use plus or minus 0, you deserve object errors. Yes, this is also true. 0 is just 0. I'm keeping an eye on the chat. It's over here in my Safari floaty window, so keep the peanut gallery going.
Yeah, if anything not Mimi comes up, I'll make sure that you hear about it.
Enhance. So what this is meant to show is that if I come in here and I hit increment, it's going to, I've turned on flash to render, but you're also going to notice that my console log runs again, and the UUID is different. So it's running these functions over and over again, over and over again, over and over again, right? They're being invoked and computed, and then likely thrown away because like this text hasn't changed. But our functions are going through this effort. So this is, what, 2018 React, 2017 React, where it's just like, oh, we're doing some like serious render stuff. We could even come into the profile and like do some of this, and we can see like, oh, look, render, sorted fruits, right? Because, and the reason that this stuff is changing is because, this is always nice, is because the props change, right? The sort function, which isn't any different than it was a second ago, is causing a re-render. And the header's re-rendering because the parent re-renders, right? So we're going to go through and we're going to memoize this. And then we're going to look at all these seconds. 1.5 to 2.9 seconds, 3 seconds to get fruit to render. It's embarrassing. Let's memoize this. And then we're going to change it with the React compiler so you can see for yourselves the difference. Now, in order to ensure that I'm not cheating, we are in React 18. And so what's the first thing we can do here? We can come into, we could probably like, this header function can just be memoized, right? So we can use memo and we can just be like, all right, so as a component, we can say like memoized header is going to be what? Memo header, right? And we can shove this whole component in here and just be like, you know what? It's fine. And we can come down and we can replace, like we would do that on, if they were in separate files, you'd probably just do that on like the export maybe. And so like anytime someone used the header, they would get the memoized version of it. All right. So we've got our memoized header. Let's sort of reset this and see what that does. Throw this away. All right. So fruit compilation. That was easy. That's an easy win, right? No, nobody's real mad at that. Unless, how many components do you usually have in your React project? Like 1, 2? No, you have like 87. Unless you're using barrel files, in which case see me after class. And then you have 887. Um, but we've at least taken out the header re-render, right? So if we come to the profiler and we say like, all right, like, did I do better? Am I doing better? It'll come through and be like, all right, we've rendered, we've sorted, we're doing our thing, and like no more header. Just poof, not rendered at all. So that's good, right? That's a good start. Excellent. All right. So now what about the rest of it? Can we get this to the point where like ordered fruits computation isn't being rendered? And yeah, okay. So we could use what? Everybody's favorite use memoization for this function, right? For our sorted fruits. Okay. So our sorted fruits gets a function and it's going to trigger that and then get this list. So you notice like our fruits here, bananas, cherries, aren't actually in the same. We should actually change this order so it's like actually let's put bananas on the bottom. Cherries, Roombas. There you go. So we're actually reordering these, I think, by it looks like alphabetically. So let's take this function because it says in here that what did it tell us? You're re-rendering sorted fruit because the sort function changed. Okay. So sort function. And sort function is ordered fruits. All right. So let's use let's memoize it. So use memo. So everybody remembers how this works. I think I remember how this works. And we'll do this. And what are the dependencies?
Yeah,
there we go. Fruit. Fruits. Is there another dependency?
The function.
Oh yeah. Did I not import use memo? All right. Use memo. All right. Oh yeah, and the function too. Okay. So sort function. So whatever that function is, if that changes or the fruit changes, then we'll recalculate. Otherwise, this sort should be the same. So the list shouldn't change, right? Yeah. Okay. Let's see how that works out for us. Clean this up a little bit. No. Ordered fruit, still coming along. So we memoized our call. Well, let's trace this callback. Sort function is a function. Here, it's ordered fruits in our main, which is where we're still getting, this is still happening. Anybody know why?
Because it's an arrow function defined in the render of the component?
Yep, it's still getting called. So this function is still getting called on render, which is triggering the sort. And the sort is going to go ahead.
They're calling for use callback because the reference equivalence is different on every re-render of the parent.
There you go. Say that again.
They're calling for using callback, use callback, because as an arrow function, every time the parent re-renders, it's a different reference value. So it recomputing the memo.
Yeah. So here in the middle of our app, we have a function that's doing like our expensive calculation. But it's a new reference every time. So as far as it's concerned, like if we come back up here, like memo's working great. Like use memo's like, yeah, sort function, different. Every time you send it to me, it's a different reference. Like, okay. So yeah, use who got that? Jesus. Yep. So the function is not recreated. All right, so use callback. Use callback. And we can do this, and we can do this, and we will do. We will just get rid of this. Can we just get rid of this? We'll do, and there's no dependencies on it. Did it import it for me? Oh, cool. Thanks, auto import. Okay. So now we've got our useMemo, in case fruit, or the function change, and the function was changing. So we came in here and like, okay, on render, just there's no dependencies here, right? We're just taking the existing fruit list, although I guess computed fruits, although we're not setting this. So I think we can sort of hand wave this for right now. All right. Do you think that's everything? That might be everything. Let's find out. So if I come in here, there we go. All right. Finally memoized. So now what we finally have is an application that is performant. And I'm using air quotes, mostly just to say we have come through the app, right? You can see like there's nothing happening here. Like now it's all just sub-milliseconds, right? It's just like render duration, non-existent, because there's nothing being rendered except for like this little, just this little piece. There's no recalculations, there's no redone. So congratulations. You have now taken computed fruits in, what was that? 10 minutes. Having done this 100 times, you've taken it and memoized it. Now, I want to stop for a second because this wasn't a huge effort, right? There's 2 or 3 spots where we've got to come in manually and sort of think about what's happening at a logical level. And, if we had, what usually happens when I do this is that I will start with like, oh yeah, fruits, right? Okay, that makes sense. And then I'll come back and it will be like, because we called back, so the function's not going to be different, is it? So that actually works too. But there usually is like cracks and stuff that I have to seal up. That I'm like, oh yeah, like the callback. I would have been like, wait, okay, because it's a new reference. Like, come down here and wrap this guy up. But that's just one file. What is this? Like 70 lines. All in one file.
Question while we're here. Isn't the function we've just used callback able to just be a pure function that lives outside the component? And wouldn't that avoid the use callback entirely? Am I crazy?
Yeah, it should be able to. Because it just takes F and sorts it. So yeah, as long as it's a yeah, certainly.
Sorry, just thinking of option 2 instead of use callback, it could have just been a pure.
Oh yeah, so let's take it out and see if that works too. Ordered fruits. Yeah, we can put that there. Now we have a utilities folder in our project, thanks to Dustin, called utils. That's just full of random helpers. But he's right, that does work, right? We can pull that stuff out of the render itself. And that works great. Maybe this is dependent on a proper use state from, maybe the count, we could put sorted by and then ascending or descending is saved here. I guess we could always pass that stuff in, right? So there are a number of ways to sort of manipulate this. What is this? Is missing a depend? Yeah, see, even like it still works, but React is like, bro, you are still missing an exhaustive dependency. So like, even though that we called back this function, the linter is still angry at us, and it would probably fail Husky, and it would probably fail your pipeline, and you can't merge it in. and then your ticket rolls over and everyone's super disappointed in you. This never happened to me though. So now let's get into the really good stuff, is getting this into a compiler sense. So we're going to stop this, and I'm actually just going to revert back our memoization changes. So I'm just going to throw all the memoization that we just did that we worked so hard for. I'm just going to throw it away. So nothing up either sleeve, bananas back at the top. That deserves to be down here. So we memoized it. It took a team of what? A dozen highly skilled, qualified engineers to find where it is, and then we optimized it. So we are going to, let's bring in our compiler. So in React 18, we're going to bring in a Babel plugin React compiler. Crunch, 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 crunch. And then we're going to come into our Vite config, and we're going to add this compiler in here as I think inside of the React plugin. So inside of React, we're going to do Babel, yep. And we're going to say Babel plugins, C. And we're going to say, I'm actually going to copy this because the number of times I've spelled Babel wrong is hilarious. All right. So we're going to use the Babel plugin compiler, but with one key difference. We are going to tell it where the React compiler config is, and we are just going to make it ourselves. So we are going to write our own runtime module for this. And in order to do that, we probably need something like that. So path is not defined. I don't really care. All right. So now we're going to add a little resolve so that we can find this inside of our source directory. And we're going to write this little file called metash. So if we start the project now, it'll be like, hey, I don't know where like this file is. Like, what's the deal? So what do you think the secret sauce for saving all of these things, all this cache work that it's going to do for all this memoization, all this callback stuff? We're going to write this out one line at a time. So buckle up. You ever been to those like ones where they're like, it was a great exercise, except for we watched him type for what felt like 2 days. This is actually, we're going to do a function. It's going to have a size. We're going to call this function C because that's what the React compiler runtime is looking for. And we're going to say use state. It's going to return a new array of size and the first item in that array. What? Oh, yeah. Don't care. And that's it. That's the whole compiler function, or that's the runtime optimization. Ta-da! We did it. You're not convinced, are you? I see doubt. Banana? Too many.
Go back to your Vite config for a second.
Oh.
On 19, are there too many?
Oh, there are too many bananas. There you go. Why would that clear up? All right. So let's take a step back and see what we're doing. We added in the package, we added the compiler, the Babel plugin for React compiler, still on 18. And then in Vite config, we said, hey, we want to use this Babel plugin. And I'm going to give you the compiler config. And the compiler config has a fair amount of options. The one that we're concerned with is the runtime module, which is the function it's going to invoke when the compiler comes across an instance using the rules of React and your component that it feels can and should be memoized or use callback. It's going to invoke our runtime module, which is now called my cache. It's going to invoke that to either fetch that cached or memorized component or compute it for us. So if we did this correctly, I believe we should be able to start this application. Fully memoized. Should we take some bets on that? Wow. Oh, path is not defined. Why isn't path defined?
You gotta import it from Node.
Really?
Yeah. I think it's just Node path now.
Like that?
I think that's what it is these days.
Do I have to do dir name too? I don't have to do
Dir
dir
name?
name.
Dir name shouldn't be a thing. That should just work.
Like, why is my linter so mad at? Like, okay. So that seemed to fire up just fine. So let's go back to our application and let's take a look. We're going to start this up. All right. So we've got our sorted fruits. I was going to do animals, and then we were at Trader Joe's and we did fruits and stuff. No, not working yet. I think we've got it. I'm looking at, there it goes.
What's in your Vite config that's different? What's that app cache, Jesse?
Oh, I just renamed it. Instead of my cache, I just called it app cache.
Did you just need to restart the server because you changed the Vite config?
Yes, maybe. So if you come over here and you actually stop it and say, hey, I changed the Vite config, it's totally happy with it. So if we come over here, so what we've done is we've said, hey, app cache is now where this file is going to be. And the only thing in app cache is this use state. Now, there's no set state. And why do you think that is?
Well, aren't you returning both the state and the set state function by default, and you're just letting C take care of it wherever it's invoked in the compiler?
Yeah, exactly. Do you think the compiler calls set state?
I hope not, but it probably does.
What happens when you call set state?
It re-renders the whole app.
Yeah, so when we pass this, the compiler, and we'll look at the actual output of it here in just a little bit, doesn't use set state. It just takes this array and does a comparison and then does some assignment of elements in the array, because calling set state would in fact cause a re-render. So if
I also just realized you're only returning the state, not the actual, not the. I thought the zero was inside.
Sorry, yeah, zero. I was going to say this should just be the first element of it.
Don't ask me why. I read that it was inside the paren.
Yeah, that's fair. I actually wrote this backwards. I spent like last week I was working on it and I was like, why does it keep? I was like, oh my gosh. I was like, this is literally like I'm copying it from the in Facebook. They have literally this function exists. And I was like typing it. And I had put this on the inside. Don't do that. It doesn't work. That's how you lose hours of your life. So if we come in here and I'm going to, we can run this and I want to take a look at this flame graph again under profiling. and just see what you can see. Like nothing's getting re-rendered, nothing but the app happening, right? Oh, look, we even get header did not re-render. We get header and fruit stuff did not re-render. They're overlapped because the debug tools is not happy with me running 18 and the compiler. It's like super mad. So you can see here it's like header and fruit not re-rendered, and it took care of all of these pieces. Now let's like just to drive this home. This is what the code looks like. It looks like this first part of our app. Right? We've got our set counters. There's like 2 use states, 3 use states. There's no callback. There's no nothing. And here it is, just doing its thing, not re-rendering at all. So if you've got a vanilla app, adding the compiler is going to basically give you all of the lowest hanging fruit. It's just going to take it and call back and memoize anything that it can using the rules of React, right? And the dependency arrays that it knows about. Because like the linter and the rules, like it knows that these are your dependencies, right? It was yelling at us a second ago. It's like, hey, you forgot one. Like it knows what they are. It's like, this is that like doing your taxes. This is what I've figured out. It's like doing your taxes in the States. And for our international fans, I'm going to give you a little glimpse into American process. So the IRS every year says, hey, you owe us some money. And you say, cool, how much do I owe you? And the IRS says, you're going to have to figure it out and then cut us a check. And if you're wrong, we're going to put you in jail. So figure it out, cut us a check. And they're like, well, can't you just tell me how much I owe you? Yeah, we know how much you owe us, but we're not going to tell you that. Just do the work first, and then we'll tell you. I feel like React in the useMemo is playing the same game. It's like, we know what to memoize, and we can do it, but we'd really like you to do it first, and then we'll check your work. It's like grade school math all over again. So there is another way. So this is how we're using state now. We're actually going to change this up a little bit. We're going to create a folder called app cache, and we're gonna you know what I'm gonna do? I'm gonna stop the configure. I'm gonna get rid of my old function. I'm gonna take my new function. So we're gonna move app cache, our C function, index.html. We're going to move it in here. We're going to add it as a separate package. And then we're going to check out some generated code of the compile. Like, let's see what the compiler actually spits out for us. Yeah. You want to like dive into the gritty parts of it and be like, what? So we're going to do, we need a package file. I need a package file. Where's my package file? There is a open project while I'm looking for my package file that keeps a polyfill of the module, which is essentially what we're going to do right now. So like, this is actually, we're going to treat as its own internal little package. So we're going to say package.json, and we're going to say it's the React compiler, it's version 1. The author is amazing, but unaccredited. And now we can come into our package, and instead of we're going to say, what are we going to say? Oh, that's right. We're going to add a dependency. And that dependency is React compiler runtime. Yeah. So when it looks for because this is what it's looking for in our beat config, we're gonna change this. So we're gonna say the compiler, and if you don't know, now you know. you can just say file, source, app cache. So what we've done over here in our app cache is now instead of a single file, we've made it a runtime package. And then we can come into our beat config, and we don't actually need, we don't tell it this, we say the runtime is the React compiler runtime. So we're saying now instead of this file, my app.cache file, I want you to find this package, which we've sort of wrapped up into this other. And it says, okay, let me find that package. Oh, it's right here. And so we've done this, and we come over here. If we start this up, should be totally fine as long as the beat is. Oh, what does this say? Failed to resolve from source. App.js does not exist.
Oh, you technically need to PMPMI.
Do I? PM install.
I got
There
you,
it
buddy.
goes. Look at that. Man, am I glad Dustin came back from vacation. We'd all just be sitting here going, huh. There it goes. All right. No, that's not true. You guys would have gotten it. Barrel file. Oh my God, you guys with your barrel files. And there we go. So it's memoized again, or memoized still, and we've sort of removed this as an entire package. Now there is this really cool playground. Check out. There, we're going to stop this, and I'm going to jump over. I've already, for the sake of time, as much as I wanted to compute these manually, I ran the computations. There's a playground where you can come in and take this stuff. So I ran a build sample. So and what I mean by build sample is, let's go over here and let's do p npm run build. Crunch, 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 crunch. Okay. So this is our app. We've got our compiler working. Here's all of our code. First of all, have you guys ever looked into this recent? Like, has anyone ever like come in here and been like, how much, what, like when they're like, well, you send the whole React library to the thing. Like, I've sort of like internalized that phrase, and I don't really see it anymore or hear it. I'm just like, whatever. But this is our entire applications that sort of bundled up. In here is our actual code. We can see like here's our fruits, right? And so what I did was I went in here and I like plucked out our actual application and sort of cut out the yelling garbage stuff and formatted it so that we could actually read it. And so you can see it's got our NC function and some other stuff. There's a prettier version that we'll look at right here. This is actually outputted. This is how the React compiler with 19 does it, spits it out so that we can actually see it. And so here's what's happening. Let's talk about the header function specifically. So this is our compiled output code of the header. So you can see it puts in _C, which is our app cache, part one. So it gets this $, it's going to use that, and it's going to say, okay, I'm going to create a variable, and if $0 is a React memo cache sentiment, great. Then I'm going to assign T to this block. So now T is assigned, and then it's going to assign the code to T and then assign T here. If it's not a cache block, it's going to assign it to 0 and return it. So it's doing the sort of memoization for us. That memo header, if you remember, we had memo header. It's doing it for us just because it knows the rules of React, the linter, and where our component is used. So it has gone through, it has calculated this stuff and said, okay, the first time, if this $0 is valid, is a symbol for the React cache, then I'm going to assign it and return it. Otherwise, I'll just assign it and then return it. And it does this over and over and over. And that's it. That's the whole tip of the spear, is that this simple function that we made on array size is just going to create a new size for each component and piece that it uses. And then it's going to, inside of that array, assign those pieces. Happened to my playground sub. One by one. So you can see, like, for the sorted fruits, it's going to go through and it's going to create 4. And it, one by one, it's going to check for the header and the list item. And then it's going to check for the sorted list. Otherwise, return that list, each item in that list. And then it's going to do 5, and then it's going to do 6. Right? And so this is, each component is going, and they're, if we've got them all cached, great. If not, assign them. And then assign that value to the element in the array of the array size for that component. Now, how it gets to that decision is really where, like, the compiler sort of magic-y part happens, is like, well, so it's going through and it knows, like, okay, this is dependent on this, and like, this isn't going to change. These ones are pretty simple. The set count we can find, is that even in here a second time? Temp to. Oh, did we take that function out? Oh, I didn't take it out in the playground. So this is interesting. You know how we took the to be sorted fruits out of the component entirely? So that
it totally
it
made
did
it a pure
exactly the same
function.
thing. Yeah. It was like, hey, I know exactly what to do with this. Like, this isn't dependent on anything. It doesn't need to be part of it. And so it did it with a bunch of other things. Now, I think that this is a good start. And if you have a bunch of, so here's the really nice thing about it, is if you have a bunch of callbacks and memoizations in your app, right? We ran it on one that is like just pure vanilla, right? That didn't have any. But if we ran it on, well, let's do it. Let's find our Memoized version. And all right, so is this our Memoized version? Great. I'm going to take this and then we're going to dump it in the playground. And that way I can show you the playground. I need a new window and I need my React playground, which you can find at Playground React Dev. Ooh. So this is the playground. I just dumped our app in here. I think I can get rid of that. And it says, cannot preserve memoization. React compiler has skipped optimizing component because the existing manual memoization could not be preserved. So it actually did this one, and then why is this? Cannot preserve, has skipped. Oh, this may be mutated later, which could not cause the value to change unexpectedly. Isn't that interesting? So because we had memoized this, this is all the compiler sort of bought us this time around. Is this where'd you guys go?
We're here somewhere.
Oh no, there you are. Oh, you're still in my browser. I forgot you were in my browser. It's like, where did everybody go? So I wonder if we take that function out, if it will, let's do this. Let's take this callback function out and see if it would actually memoize this, or if it's still like not okay with that. So we can take this out. Okay, so we got more out of it, but not only the function that we pulled out of it. It still hits this memoization, and because it's already memorized, it will just skip over it. What happens if we like memoize it wrong? It will still skip over it. Huh. What happens if we don't memoize it? What do you think?
Yeah, I feel like it's going to do exactly what we want it to do.
Yeah, it should do.
I mean, it kind of makes sense. You've already gone through the effort of memoizing something. You've told the compiler how you want it to behave. So for backwards compatibility reasons, it's going to just
It's
respect
just,
your
yeah.
chosen memoization path.
And so what I found out in preparing for this is that it will safe skip anything that is even remotely questionable, right? So we've talked about like, some of these, if these components match the different elements in the cached array that it's already checked over, and dependencies and conditions, like if this dependency is met, if this dependency, if this, you'll get into a lot of situations where there's enough turtles all the way down that it will bail on you and just not optimize it through the compiler. So this is just playground.react.dev, where you can sort of drop in your code and see what the actual JS output is going to be. And it matches pretty close to, if we go to our finished code that we had outputted ourselves, that looked like, so that was good. Oh, yeah. Status. Highlight local branch. Oh, there it is. Build sample. So this is what we had outputted from our code into the disk that I'd cleaned up. So this is the compiler. You can see it. It's checking, and then it's either going to run this sort of JSX assignment, or it's just going to pull that component and it's going to pull that JSX out and assign it, or it's just going to fetch it from the existing array that it's already got. So this is pretty spot on. You can see some old school sort of JS elements with class names that has children, that has onclicks. And then at the very bottom, the create root React. Of course, in strict mode. Now the compiler is, as far as we know, it is used extensively in like Instagram and Facebook, and is in experimental or beta in React 19. We've just shown here this morning that we can run it in 18. You just need to use the Babel plugin config to invoke it. I don't recommend it, but there is an entire polyfill project that you can grab, and the function's a little more, what's the word I would use? So this is our function that is just the use state. But if we do, let's do polyfill React compiler. Using the React compiler, yeah. No. I think this has got a link to the polyfill in it. Oh, the official polyfill. Yeah. Oh, so this is the actual function in React compiler. It does just a little bit more. And then adds the symbol to do some React Dev tools. And then does some read. And then there is also a working group that does a polyfill. This should look familiar. It creates an empty version and then does an iteration over it before it returns is empty true on that. So a little more checking on there, but nothing that isn't. I think these were added in 19 to do some dev and check for empty space. So with that, I want to open it up to the floor and see who's got questions about the compiler or working with 18 or memoization, and go from there.
You go to your compiler function for a second, because that's
Sure.
my first question. So looking at this, we're returning an array of size. So is size in this case just the number of or renderable elements within the entire application that React's detecting, and then it's just creating a memo array at the global scope? Am I understanding that correctly?
So if we look at the, let's look at the playground sample. So for each component, it's going to create the number of elements that it has. So like this one uses 15. I think the size is.
Okay, so it's creating a state for every component file.
Yes.
And memorize it. Okay. That
Yeah,
was the first thing.
each.
I was like,
Yep.
what
is it using that size for? Yeah. So for each
Yeah.
one, so like T0 here refers to the header element, but not like each component has its own internal app cache state memoization.
That makes a lot of sense. Well, now here's the next question. Line
for the size.
12. Go back up to, or actually stay where 12 or wherever you are. Okay, line 12. We're now, I know we said we're not passing a set state, but this is mutating the global memoized state array.
Yep.
Which that feels faux pas. Why can we do this and not get in trouble?
So we can do this assignment because it doesn't change the array reference. The reference still remains the same to the array, but we can manipulate the elements and assignment in it in a calculated fashion. Like this is very much against everything in your body, like for the last, 15 years? That's like, are you literally just assigning this to that element space? And it does this specifically so that it doesn't trigger a re-render. So to keep it out of the space of set state.
I feel better now. I was like,
Yeah.
What am I not reading right now?
Yeah, as soon as like a couple weeks ago when I dug in and I saw this, I was like viscerally upset. Like my heart rate went up. Like I started to sweat a little bit because I was like, what? Like everything in my body said, don't assign directly to an element in the array. Like, what are you doing? But the reason became pretty clear that it is doing so because we have given it permission to manipulate that array, and that that array only exists in this, like access to it only exists in this function without any other available options to like mutate it. So once the array is created, the reference stays and it can change those accordingly. Yeah, it was a total trip when I came across this and was like, how is that? One, the $ gave me like huge jQuery flashbacks. So once I get over that initial PTSD, Um, then I tripped over the direct assignment.
I took it as they're punning on the word cash and it's cash money, and therefore I
Money.
sorry, that's where my head went when I saw it. But I hear you on the jQuery. So, so maybe here's a good question for you. Like, okay, compiler's not really React 18 ready. You could polyfill it. You're not recommending it though. React
Definitely
19 is
not.
gonna have the compiler. There's gonna be a path forward. Um, we all have probably a ton of production apps today. We've got probably hundreds of use memos and use callbacks in a variety of different contexts and applications. Like, what's your recommended path for migrating from not having the compiler to having the compiler?
That is a fantastic question. Uh, what I would recommend is to move up to 19 when you and your group have some time. Run the compiler and see what the ES linter is going to give you a lot of feedback. Like you're going to get a lot of feedback, like we saw in the playground, which has there it is. In the playground, you're going to see a lot of like compiler unable to do thing. The linter is going to do a fair bit of that. You're not, because it is such a double safe like fallback. You are not. I don't think you're going to lose anything by running the compiler. Uh, and then what I would suggest is that you and your team decide like, okay, if you're going to go in and touch this, like we've ran the upgrade, we run the compiler. There's no like catastrophic. Like it will even skip over. Like if you do some like in the beginning, I talked about JSON stringify this dependency to like force it to rerun. Like if you're doing some real hokey stuff, the compiler is just going to skip it. Like it's a sort of like default status. So I would even say it's safe to run 19 and the compiler. In the worst cases, it's just going to skip over everything. And then you and your team need to decide, like, if you go into that file and there's like 3 callbacks and a memoization, like if you touch it, you clean it, right? We used to have a rule on one of my old teams, like when we were migrating from Angular 1 to React, it's like if you need to touch this file, you now are in charge of converting this file one by one by one, right? So I think you're going to see a point maybe in a year or two where there are going to be version bumps of new libraries that are only compatible with the compiler, like that are only compatible with 19 plus, like because the way, like one example is MobX. MobX is not compiler compatible, full stop. You may be wondering why. MobX uses proxies, and the compiler has no way to reference or understand. Like there's no sort of computational way for it to understand the proxy of state management. So it thinks that everything is changing constantly. It doesn't understand, like the references are different all the time. Like it doesn't know that. So it's like if you're using MobX, you could turn on the compiler and it's going to skip the entire thing. Like your entire MobX is like not worth. They probably have their own upgrade paths for that. But for the rest of it, I would say go slow. This isn't something that it's going to buy you a lot. I would enable it and just maybe leave it on as a default and then continue the way you are. New components, you probably skip them and check them. And then decide as a team how much you want to visit already existing code. And just clean it up. If you've already written them and it's not going to optimize it, guess what? It's already optimized. So congratulations. It will put in use call and use memo if you have them, and it will replace them if it meets the dependency standards. So you're not losing anything, and it may clean it up for you. But if you already memoized it, it's not going to get any better. Does that make sense?
It does, and introduce. Or Rob, maybe you want to say something.
Go ahead.
I was gonna say it does, but I think it introduces an interesting thing based off of the playground example we had earlier, where we had that use memo and it just skipped the entire rendering block at that point.
Yep.
Does that mean that child components in some cases will be full skipped. So is there a risk of like, hey, you're in a child component, but its parent um hasn't been unraveled, and therefore the optimization of the parent would impact the compiler's ability to handle the child?
Oh yeah, it will absolutely skip that. It is um, what I would call double blind safe. It will absolutely skip that child. If it can't memorize the parent, it will not go any further down that tree stack. Um,
So
although, wait,
the
is it
the
an imported child?
yeah, I guess that's my question because I mean we're doing one
Yeah, no, that's
file, it's flat, so it's kind of the question of like, hey, are we in a situation where if a parent is getting skipped, does the whole child tree get skipped? And if that happens, is the whole you see it, you fix it strategy fail in our face on step one?
well.
So
Let's do
that's the
this.
only reason I'm asking.
Yeah, so let's put this back in here, and we've got our thing, and now let's put our header in our. Let's see, memorize header, and let's put it. So this is the function that it stopped on
Yep.
because of this. So let's put our header. Let's put our regular header here and see what it does.
Ooh, I like that. Good example.
Yep. And let's take it out of here so that we don't have memo. Yep, it came through and it skipped over this part, but it did spit out this child component.
Okay, so we do have skip level compilation.
Yeah, as long as there isn't something in the it'll check the child, and as long as
Oh,
com-
can you kill 10
cannot
real quick?
preserve. What's that?
Can you kill 10 just in case? Uh, I'm just worried about it is being
Oh,
memoized on 10. Okay, now I feel good.
yeah, yeah. So preserve memoization, it will still check child components and execute on them if it can. Did I say that right? Yeah, if it can.
I think I can. I think I can. I think I
Yeah.
can.
Now you may be ready for a real hot take. I think this is too little, too late for React. It's a like we've spent years like adding uh, a lot of ceremony and nuance to it that most of us don't get right. I would say most of us in this room have to put in a lot of hours to get it working. Right? It took what 16 of us 10 minutes to fix one file to render correctly. Um, it's nice that the compiler can do all this stuff for us now, but it feels like a little too little, too late for the React library. Now, does that mean that I'm not going to continue to use JSX and React and the ecosystem? No, it's got a lot of momentum and it is pretty useful. But um, you know, does anyone really like handwriting memoization? And you're going to see it for years to come, right? So that's my spicy take.
Has Vercel spoken on this issue at all? Is there any sense of where compiler and next will intersect, or is that for next conf?
I think that's probably next. So they're using Vercel and Next is using. They're not using Babel to compile. They're using SW, aren't they?
You could literally say anything, and I'd probably believe you.
Yeah, they've got their own compiler using SWC.
SWC is less of a compiler though. It's more of it's like their own Babel transformation tool. So it's like oh
It's
well
like
like
yeah, it's their own babbler basically, right?
it's like their own V is another way to put it. But it's Babel. It supports Babel.
Does it support Babel?
Um Yeah, it's like we were talking about RS Pack this morning.
Oh yeah, I like our
It,
spec.
it's like RS Pack in a lot of ways.
Okay.
So it's just a layer. So you could play. I mean, I'm pretty sure Jonathan said this to us, but I'm 90% sure SWC supports Babel under the hood, which means any React 19 Babel plugin would work in this, and so you would get it for free in Next.
Yeah. So like where we put so let's I would consider it this way, like where we put in our application where we had come into Beat and added these Babel plugins manually. I get the feeling that you can come in and tell the next compiler specific Babel plugins that it will pipeline and use, right? So it sits on top of Babel and takes everything in and then does what it wants to and then runs those certain things through Babel on the other end. Yeah, because it's got all sorts of options that will get passed down to Babel. Um, Part of me also thinks that this is a lot of work and a lot of mind share and a lot of mental effort to get back to square, like to get back to uh, even. Uh, I remember specifically, I used to do iOS development when the iPhone first came out, and we had to do reference. You or I remember this, Rob. We had to do reference counting ourselves. We had to instantiate and release assignments manually. There was no automatic reference counting or releasing of Objective C until like the iPhone 4. So like 2012, 2013. Before that, we would alloc and dealloc everything ourselves, or you'd have a huge memory leak. And on the old phones, it would just crash. So like, I feel like I've gone through this once before, but like with like C. And it's like, oh, it's really nice to have, but like we're still like, did we really have to go through this like 4 year journey in order to get here? Was there not a better path forward? I don't know. I don't know. Uh, yeah, Arc was definitely oh, good old Malik. Arc was definitely a lifesaver for most of our apps. Yeah, Objective C memory management. If you really like looking for snooze, that's your thing. So I want to thank everybody for coming and digging through the compiler with me. It can be a real snoozy topic, but it is really interesting to look far deep under the covers and see what is happening. I hope that everyone picked up at least a little tidbit of like, is it really doing direct assignment? And yes, it is. But it's pretty interesting, and we'll see. I would like to see like better ecosystem tooling instead of 37 compilers that is still just smashing all of our JavaScript into a gulp file.
And with those React compiler configs, very close to getting decorators, and then the great union of Angular and React be at hand.
Yeah. Oh, decorators.
Yeah, well, why don't you help everybody know where they can find you online?
Yeah.
What
You can
social
find me
networks
at
you frequenting these days?
so you may have known I spent a lot of time in the Mastodon ecosystem at jtomchak at moth.social. But you can also find me on Twitter, jtomchak at Twitter. At jtomchak. I almost don't even know how to say it anymore.
What's my name? Where am I?
What's my name? Um, I'm also on Threads quite a bit too at jtomchak. So you can find me at any of your favorite places at jtomchak. On the Fediverse, on the Thread Fediverse, the unfediverse of Twitter X. I'm available all those places. Pop in and say something salty about React or compilers, and we can talk all afternoon.
Or soccer or your upcoming fantasy team, whichever.
Yes, if you want to talk Premier Soccer or League One or Two, or youth ECNL soccer, I'm in it up to my eyeballs.
All right. Well, thanks, Jesse. Thank you, everybody, for attending this training. If you have any questions, feel free to ask them in the comments, and we'll hopefully be able to get an answer for you. If not, if you have recommendations or suggestions for future trainings, let us know that as well. But otherwise, hope to see you at the next one, everybody. Have a great day. See you all later.
This program is presented by This.Labs, a framework-agnostic consulting firm helping enterprises realize their technical goals through staff augmentation, consulting, project management, on-demand subject experts, training, and other professional services. Find out more at This.Labs.com.